Connecting two metals repels all insects. The Earth battery secret. In 1747, inside a stone laboratory in Paris, a physicist named Abbé Nolet noticed something he could not explain. He had two identical pots of soil sitting side by side. Same seeds, same sunlight, same temperature. The only difference was that one pot was connected to a source of electricity. The electrified seeds sprouted days ahead of the others. But that wasn't the strange part. The strange part was the insects. Small flies swarmed around the normal pot, but they refused to go near the electrified one. They hovered at the edge, then turned away, as if hitting a wall that wasn't there. Nolet wrote it down. He published it. And then, for 270 years, nobody followed up. Today, we are going to follow up. What you're about to hear is a story that stretches from 18th century Paris to the trenches of World War I to a peer-reviewed German laboratory in 2015. Along the way, you will learn about a device that costs less than $5, runs on nothing but damp soil, and may be one of the most effective natural insect deterrents ever documented. Some of this is proven, published science. Some of it is historical mystery that the scientific establishment has never bothered to explain. I will tell you exactly which is which. This is Historia Prime. Let's open the vault. Section 1. The experiment that started everything. Let's go back to that Paris laboratory and look more closely at what actually happened. The year is 1747. Europe is in the grip of what historians call the age of electricity. Benjamin Franklin is about to fly his famous kite. Across the Atlantic, French scientists are racing to understand this invisible force that can make hair stand up, spark fires, and, some believe, animate life itself. Abbé Jean-Antoine Nolet was at the center of it all. He wasn't just any researcher, he was the personal physicist to King Louis XV of France. When the king wanted to see electricity demonstrated, it was Nolet who obliged, once famously sending an electric shock through a chain of 200 monks just to see if electricity could travel through human bodies. It could. But Nolet's real passion was quieter. He wanted to know, does electricity affect how things grow? So he set up a simple, elegant experiment. 2 pewter vessels, identical soil, equal quantities of mustard seeds. Same room, same light, same water. The only variable, one vessel received an electrical current for 10 hours each day. Within 3 days, the results were undeniable. The electrified seeds had already broken through the soil. The control seeds hadn't even cracked their shells. Nolet documented everything and published his findings in 1749, concluding that electricity accelerated evaporation in the soil and the upward movement of sap through plant tissue. But buried in his notes, almost as an afterthought, was that other observation, the one about the insects. He noted that small flies congregated freely around the uncharged vessel, but the electrified pot sat in what he described as a zone of isolation. The insects simply would not approach it. Now, here is what makes this remarkable. Nolet was a meticulous scientist. He didn't exaggerate. He didn't theorize about why the insects avoided the electricity. He simply recorded what he saw, and what he saw was an invisible boundary that insects would not cross. The scientific world read his paper, praised his work on plant growth, and completely ignored the insect observation. For nearly a century, it gathered dust. Section 2. Dirt, metal, and an accidental discovery. Fast forward 94 years to 1841. We're now in Edinburgh, Scotland, in the workshop of a man named Alexander Bain. Bain was not a scientist, he was a clockmaker, a tinkerer, an inventor, a man who solved problems with his hands. He had no interest in abstract philosophy. What he wanted was a cheap, reliable source of electricity to power his clocks without using the expensive chemical batteries of his era. One day, Bain had a deceptively simple idea. He took 2 metal plates, 1 copper, 1 zinc, and buried them in the wet soil behind his workshop, roughly 1 meter apart. He ran a wire between them above ground and connected a voltmeter. It read approximately 1 volt. No acid, no chemical bath, no generator, just 2 different metals and damp earth. What Bain had stumbled onto was basic electrochemistry. The moisture in the soil acts as a natural electrolyte, a liquid medium that allows ions to migrate from one metal to another. The zinc, being more chemically reactive, slowly gives up electrons. The copper collects them. A current flows continuously. He called it the Earth battery. And it worked. It powered his clocks for months at a time without any maintenance. But here is where the story echoes Nolet's. Bain noticed something odd in the soil around his buried metals. Earthworms seemed to thrive between the plates. They clustered in the mild electrical field as if it was somehow beneficial to them. But biting flies, they evacuated the area entirely. Bain wasn't a biologist. He didn't pursue this observation. But someone else did. In 1844, a Scottish landowner named Robert Forster read about the Earth battery and decided to test it at agricultural scale. He installed a network of copper and zinc plates across his barley fields near the town of Elgin in northeastern Scotland. The results were published in The British Cultivator in March 1845. Forster reported that pest damage to his crops had dropped to near zero. No aphids, no beetles, and, critically, the workers reported that at dusk, when clouds of biting flies normally descended on them, the insects seemed to halt at the edge of the fields and turn back. The Royal Society acknowledged the findings as remarkable. Agricultural journals discussed them approvingly, and then nothing happened. No large-scale trials, no follow-up research. The Earth battery remained a curiosity, brilliant, documented, and completely ignored. Body Section 3. The man who grew 7-foot oats without fertilizer. But the idea didn't die. It went underground, literally and figuratively, until it surfaced again in the early 1920s in the hands of a French engineer named Justin Christofleau. Christofleau was frustrated. He was watching French agriculture become increasingly dependent on synthetic chemical fertilizers, expensive products that degraded the soil over time and did nothing to address the constant plague of crop-eating insects. He had read the old literature on electroculture. He knew about Nolet, he knew about Bain, and he believed that the Earth itself, and the atmosphere above it, were saturated with electrical and magnetic energy that farmers had simply stopped using. So he built something that must have looked insane to his neighbors. Picture a 25-foot wooden post planted in the middle of a farm field. At the top, intricate spirals of copper and zinc wire reach toward the sky like a strange metallic flower. Below the ground, more wires fan out into the damp soil. The entire structure is carefully aligned south to north, following the axis of the Earth's magnetic field. He called them electromagnetic pterocelestial antennas. The name sounds theatrical, but the engineering was deliberate. The above-ground structure was designed to capture atmospheric electrical charge, the same static charge that builds before a thunderstorm. The buried wires tapped into what geologists call telluric currents, the natural electrical flows that move continuously through the Earth's crust. The claim was that these combined energies would create a continuous flux through the soil, stimulating plant growth and driving away pests. And according to Christofleau's documented results, that is exactly what happened. His oat crops grew over 7 feet tall. No artificial fertilizer. His grapevines, previously ravaged by the devastating phylloxera plague that had destroyed vineyards across Europe, recovered completely and produced heavy harvests of sweet fruit. Most significantly for our story, he stated that the electrical field eliminated insect pests entirely. No chemicals, no sprays. His theory was that the electrical vibrations in the soil disrupted the sensory systems of parasitic insects, making the environment unbearable for them, while having no negative effect on the plants, the soil microbes, or the earthworms. This was not a fringe experiment. Christofleau patented his devices and sold over 150,000 units across Europe. Entire farms operated pest-free, using nothing but copper, zinc, and wet earth. So here is the question that should be keeping you up at night. If 150,000 farmers bought these devices in the 1920s, why have you never heard of them? Topic: How explosives became pesticides. To answer that question, we need to follow the money, and the trail leads straight through 2 world wars. In 1912, an international conference reviewed the accumulated evidence for electroculture. The consensus was clear. It worked. The science was real. There was talk of large-scale adoption. Then, in 1914, the First World War tore through the heart of European farmland. Millions of men left their fields for the trenches. The infrastructure of agriculture, including the networks of electroculture devices, was physically destroyed. But something else happened during the war that would change agriculture forever. The factories that manufactured explosives for the battlefield, the plants producing ammonium nitrate, chlorine gas, and phosphorus compounds, suddenly found themselves without a market when the fighting stopped. They had massive industrial capacity, they had huge stockpiles of chemicals, and they needed customers. The solution was elegant and cynical. Repurpose the chemicals of war as the chemicals of farming. Ammonium nitrate, the base of high explosives, became nitrogen fertilizer. Organophosphate nerve agents were reformulated as insecticides. The chemical industry didn't just enter agriculture, it consumed it. By the time the Second World War ended, the transformation was complete. In 1946, the United States Army developed DEET, originally designed as a chemical repellent for jungle warfare. Within a decade, it was being sold in every drugstore in America. Think about that transition for a moment. A technology born on the battlefield, formulated to protect soldiers in extreme combat conditions, was repackaged and marketed to families for backyard barbecues. And the Earth battery? The device that cost pennies, ran on dirt, and could not be patented. It was simply forgotten. Not disproven, not debunked, just made irrelevant by a new economic reality. Let me put some numbers to this. Today, the global insect repellent industry generates an estimated $5.57 billion per year. The business model depends entirely on repeat purchasing. You buy a can of repellent, it lasts a few hours, the bugs come back. You buy another can. Now consider the Earth battery. A few dollars worth of copper and zinc wire buried in the ground once, recharged by rain. No refill, no subscription, no brand loyalty. One journalist at the time put it perfectly, though no one was listening. They didn't abandon the Earth battery because it didn't work. They buried it because it worked too well, cost too little, and lasted too long. It didn't just repel insects, it repelled profit. Section 5. The modern science. What we can actually prove. Now I need to be straight with you, because this is where Historia Prime is different from other channels. Everything I've told you so far about Earth batteries repelling flying adult insects comes from historical accounts. They are well documented, they are consistent across multiple independent sources and 170 years of observation, but they have not been tested under modern, controlled laboratory conditions. No peer-reviewed randomized controlled trial has been published on galvanic Earth batteries as flying insect repellents. Why not? That's an important question, and we'll come back to it. But here is what has been proven in modern science, and it is just as remarkable. Let's talk about mosquitoes. Mosquitoes kill more humans than any other creature on Earth. Not lions, not sharks, not snakes. Mosquitoes. Through malaria, dengue, Zika, and a dozen other diseases, they are responsible for an estimated 700,000 deaths every single year. And for decades, our primary strategy has been to dump synthetic chemicals into the water sources where they breed. In 2015, a team led by Dr. Norbert Becker at the German Mosquito Control Association in Heidelberg published a study in the peer-reviewed journal Parasites and Vectors that changed the equation. They took simple plastic containers filled with water and mosquito larvae, the same type of standing water where dengue and Zika vectors breed in cities around the world. Then they introduced different forms of metallic copper, ordinary euro coins, copper tubing, and a thin spray of metallic copper. The results were devastating for the mosquitoes. At concentrations below 500 parts per billion of dissolved copper, every single mosquito larva died. Every species they tested. 100% mortality. When they sprayed the inside of a container with just 2 grams of metallic copper, it killed every newly hatching larva for up to 3 months straight. The mechanism is well understood. When copper interacts with water, it slowly releases copper ions. These ions accumulate inside the larvae and systematically destroy the gut microbiota, the essential bacteria that the larvae need to digest food and develop. Without these bacteria, the larvae cannot grow. They die. And here is the part that makes this practically miraculous for human use. The concentration of copper that achieves 100% mosquito mortality, 500 parts per billion, is 4 times lower than the World Health Organization's safety limit for drinking water, which is 2 parts per million. The water that wipes out every mosquito larva is literally safer to drink than your tap water. There's more. Recent biological research has identified that insects, like mosquitoes, possess specialized sensory neurons that are highly sensitive to copper and zinc ions in their environment. If a zone is saturated with these metal ions, through slow galvanic corrosion in moist soil or through copper dissolving in standing water, the area becomes chemically repulsive to them. They detect danger and they leave. This is not alternative science. This is published, replicated, mainstream entomology. Now connect the dots. An earth battery slowly releases copper and zinc ions into damp soil through galvanic corrosion. That is basic electrochemistry. Insects are demonstrably repelled by copper and zinc ions. That is basic entomology. The historical accounts describe exactly this effect. Insects avoiding areas where copper and zinc are buried in wet ground. No individual piece of this is controversial. The only thing missing is the single controlled study that ties it all together. And who is going to fund that study? You cannot patent 2 metals in dirt. You cannot brand the earth. The absence of corporate research is not evidence that a method fails. It is evidence that no one can profit from proving that it works. Section 6. Your $5 blueprint. So here is how you test it yourself. What you're building is a basic galvanic cell. 2 different metals act as electrodes. The damp earth between them acts as the electrolyte. When moisture connects the metals, electrons flow from the more reactive zinc to the copper, and ions slowly disperse into the surrounding soil. This is the same chemistry that powers every battery you have ever used, just spread out over a patch of ground instead of sealed in a cylinder. Here's your blueprint. You need 3 things from any hardware store. First, bare 14-gauge copper wire. It must be uninsulated, bare metal that makes direct contact with the environment. Second, galvanized steel wire, also 14-gauge. Galvanized steel is coated in zinc, which is your reactive anode. Third, a wooden stake or bamboo rod, about 3 feet long. Take roughly 3 feet of copper wire. Wrap it in a loose spiral around the lower portion of the stake. Then take 3 feet of the galvanized zinc wire and wrap it around the same stake in the same manner. Both metals need to touch the soil when the stake is planted, but the copper and zinc wires should not directly touch each other above ground. Drive the stake into the ground so that at least 6 to 12 inches is buried. And here is the most critical requirement. The soil must be damp. Moisture is everything. It is the electrolyte that allows ions to flow. If you're working with dry soil, pour a bucket of water around the base to activate the system. For a campsite, build 3 stakes and place them in a wide triangle. 1 near your tent, 1 near your cooking area, 1 near the fire. 3 stakes in a triangle can cover roughly 225 square feet. And for standing water puddles, rain barrels, bird baths, any place mosquitoes breed, simply drop a coil of bare copper wire directly into the water and leave it there. Based on the Heidelberg research, this alone should achieve near total mosquito larval mortality without introducing a single toxic chemical into your ecosystem. Total cost? Under $5. No batteries, no refills. Rain recharges the system naturally. One camper in Ontario who tested this triangle configuration reported that mosquitoes, which had been relentless the previous night, stopped approaching his camp entirely. He described them hovering roughly 15 feet out, as if bouncing against a barrier he couldn't see. Is that a controlled scientific study? No. Is it consistent with 270 years of independent observations from Nolet, Bain, Forster, and Christofleau? Absolutely. The only way to know for sure is to try it yourself. Let me bring this full circle. In 1749, Abbé Nolet watched insects flee from electrified soil in a Paris laboratory. In 1841, Alexander Bain powered a clock with dirt and noticed the flies had vanished. In 1845, Robert Forster documented pest-free fields across his Scottish farmland. In the 1920s, Justin Christofleau sold 150,000 devices to European farmers who swore they worked. Then came the wars. Then came the chemical industry, and a quarter millennium of quiet, careful observation was replaced by the hiss of an aerosol can. The mainstream scientific establishment will tell you that more research is needed. They're right, it is needed. But for 270 years, no one has funded it, because you cannot monetize 2 metals in the mud. Meanwhile, the copper still conducts. The zinc still reacts. Every patch of damp ground on this planet is a battery waiting to be activated. The science of copper ions killing mosquito larvae is not a theory. It is a published, proven fact. And the historical record of galvanic fields repelling insects is too consistent, too widespread, and too well documented to be coincidence. We traded this elegant, natural relationship between copper, zinc, water, and earth for a spray can filled with a chemical that was originally designed for jungle warfare. Not because the old way failed, but because the new way was profitable. This weekend, spend $5. Buy the wire, bury the metals, add water, film what happens. Post it with the hashtag #EarthBatteryTest. If enough of us do this, if enough of us generate the evidence that no corporation will ever fund, we won't need to wait for permission from the establishment. We'll have the data ourselves. The greatest secrets in history are often buried right beneath our feet. This is Historia Prime. Stay curious.